All right, we are going to be looking at section 1.2, which is the measurement of segments and angles. Part of the reason that we're making this a video is a lot of these terms are already going to be familiar with you. So we're going to work through, but at any point this moves too fast, the note key is also posted and you can look at that as well. So let's get started. So we have a number of types of angles to define, as well as a couple of other relationships between angles and segments. So let's start with the first one. An acute angle is an angle whose measure is less than 90 degrees. So I have drawn an example here. So typically an acute angle is smaller than a right angle, and I picked an example here of 40 degrees. All right, next up is a right angle. A right angle, hopefully you know, is an angle whose measure is exactly 90 degrees. So it will always equal 90 degrees for a right angle. One important note in geometry, if you haven't seen this before, for a right angle, right angles are denoted by a box in the corner. So you can tell that something is a right angle, whether it is given in the problem or if they mark the angle with a box in it. That is going to be a given or allow you to know that this is a right angle. All right, next up is an obtuse angle. All right, an obtuse angle is an angle whose measure is greater than 90 degrees and also less than 180. So it cannot be bigger than 180 degrees. So you'll notice that all of this is based off of a right angle. Is it bigger? Is it smaller? Here's an example of an obtuse angle that I estimated to be 120 degrees. And then lastly, our fourth type of angle measure is a straight angle, is an angle whose measure is exactly 180 degrees. That would also make it form a straight line, hence the name. So I have drawn this here. Notice how I did indicate a vertex point so that we can see it does have a vertex, but it's straight with the other points along that angle. Okay, we have two more definitions in this set, and then we have a couple more things to look at here. So next up is, how do we prove, or what does it mean for two angles and segments to be equal to each other, and what's the language we use behind that? In geometry, when two angles or two segments have equal length or equal measure, then we say that those are congruent, sorry, it's moving on me, are congruent angles or congruent segments. So if two or more angles have equal measures, then they are congruent to each other. Same for segments. If two or more segments have equal length to each other, then they are congruent. Now, a couple notes here. Notation is going to be really important here. The notation for congruent, I'll put it over here, is this equal sign with a squiggle on top of it. So that means that they are congruent. So they are the same shape, they are the same size, they have the same measure. So looking at this here, so here's a statement. What this means in symbol form, if angle A is congruent to angle B, then, now if you want to just talk about the measure, the number of the degrees of this angle, we're going to say the measure with an M in front, and then we're just going to use an equal sign of angle B equals the measure of angle A equals the measure of angle B. And then for segments, same thing. We have a bit of a notation change. So to say that two segments are congruent to each other looks like this statement here. AB, with that segment line on top of it, is congruent to segment CD. If you write without the line on top of it, you're just talking about the length, the specific number for how long it is. AB is equal to CD. All right, final important thing on notation is, how do we actually mark that in a diagram? That's going to become more important. For angles, to mark they're congruent, you are going to use these arcs in the corner. You can stack the arcs for more congruent angles, and then for segments, we use tick marks. So you can use one tick mark on each segment, means that segment AB is congruent to segment CD. Okay, got a couple more things to note here, and then we will be finished. We're just doing this first page today. All right, a few things to define. Next up is a postulate. A postulate is a statement that you can assume. So this is something in geometry that we cannot prove, we can assume it. So our first postulate that we are going to learn says this: To every pair of different points, there corresponds a unique positive number, which means between every two pair of points, it's a fancy math way of saying between any two different pairs of points, there corresponds a unique length. So that hopefully might seem obvious. Okay, yes, there's going to be a length between them, and that's why it's a postulate. We just need that to be. So again, we talked about notation. So AB without the line stands for the distance from A to B, or the length. And then AB, segment AB with the line segment on top of it, is specifically talking about the object of the segment within points A and B. Similarly, to every angle, there corresponds a real number between 0 degrees and 180 degrees. So every angle has a measurement that we can find between 0 and 180. Last thing to talk about, and then we're finished, is the angle addition postulate. Again, hopefully postulate should be fairly intuitive, something that makes sense to you. But with geometry, we want to make sure that we state things. This is how we build it. So here's the angle addition postulate. This one you will need to write out, so you can always check the key. Here it is. I'm going to do this for this example. So for this example, I've drawn an angle BAC. Inside that angle, I've drawn a ray AD. And here's the postulate. If D is a point on the interior, the inside of angle BAC, then the measure of angle BAD that I've highlighted in yellow plus the measure of angle DAC highlighted in green equals the measure of angle BAC, the whole entire angle. So this two parts make a whole. If I add the two parts that an angle is split up to by an inside ray, it should be equal to the measure of the full angle. So that is our notes for today. Tomorrow in class, we will work through the problems. We'll work through the practice. So you do not need to worry about those. That is our work for today. If you need to check the notes or go back into the video for anything, it is up and available for you to look at.